Alright, I've been trying to do this video for quite a while, and I want to get it out of the way because I've got lots of things I want to get onto. But I thought we'd do some Arduino stuff, and today we're going to look at this thing here. So it's making a little pretty pattern with the LEDs. The important thing here is we're using the 74hc595 from a few videos back, and I mentioned it at one point that it's a useful IC for expanding the outputs essentially on an Arduino. In fact, you can expand the inputs in a clever little way, but I'm not going to go into that today. But it's what we're using it here for. So there's actually only 3 pins being used on the Arduino, these ones here, and then these are being connected up to the latch clock, the shift clock, and the data in on this IC, and that's what's actually doing all the work. So I mentioned doing that in the previous videos on this. I don't think this one's working. Oh, it is working. And I said I wasn't going to go into it because there are thousands of videos on the internet about how to use that and lots of tutorials about how to do this little trick. But I am going to do it, but I'm going to do it mainly actually to just talk about a bit more of some advanced. What have I done to this thing? All the little this thing's this poor Arduino has had a very bad day. I've gone and ripped all the things off the analog input pins, so this has been sitting around and being squashed a lot. It makes me a bit sad, but I've got a ton of these things, so that's okay, and it still works, so that's all that matters. We're not going to do any analog input on this thing, but anyway, we're not here to discuss me breaking things. What we're going to talk about is advanced C programming stuff, or Arduino C programming, and a sort of like a neater way of developing this. So it's not really about the you will see how to actually use the 74hc595, but we're going to go into more detail about writing classes basically in C, and we're going to cheat. We're not going to write them the best way of writing them. But we are going to talk about. We're going to write the simplest way of making a class in C, without all the headachy, over the top boilerplate code that you have to usually add in. We're going to write like it's Java. So hopefully this is actually visible on the camera. Maybe I should just zoom in a bit. We will do the zooming in thing. We won't have the lights. But anyway, you can see it's going through all these little patterns, and we're going to explain the patterns in a minute. I'm going to put that there, and then I'm going to zoom in just a little bit. I always forget how to zoom in. There we go. So, maybe I have to zoom back out of it. Oh dear. I want it to exactly fit the page. There we go. Okay, so we're going to start with the top here. So this bit here we're going to explain a bit later on, but I'm just using, this is basically a lookup table for particular numbers that I'm going to use in order to add functionality to the class, which is coming up next. So we're going to come back to these numbers here. I'm going to present this in not the best way, but the way that I wrote the code. And the thing about this is that the code has to be written in a specific order. So C, at least the way that I know how to use it, generally requires things to be declared before you can use them, which is kind of annoying. I'm not entirely sure. I'm not a C programmer, so I'm not entirely sure why this persists until today, why this has to be continued on with, why you can't just declare something later on and then use it like you could in any other language. I'm sure there is a reason. I do one of my things is in fact compiler design and language design, and so I am a bit confused by it, but I'm sure there is a reason, and I'm going to explain what I mean in a second. But for now, to get this all to work, you have to actually code it in a particular order. So this has to be at the top of the file because this thing is used by this class, and this class has to be defined before everything else, otherwise everything else can't see it. So this is just an array of numbers, so we'll come back to that, and this is a class. So a class, I don't know what the best way of explaining what a class is, but it's just a way of describing types of objects. So this is object-oriented programming, simple object-oriented programming, where you describe a type of object, and an object is a group of data plus a group of things that you can do to that data. I guess is one way of explaining it. I don't know what the best way of explaining this is. You can look it up, but I'm just going to go through how I'm going to write this in here, and there's actually a lot better ways. Well, there are different ways of doing what I'm about to do. So the first thing I'm doing here is you have to have a pen. So first we have to say it's a class, and we're going to name, what's the name of the class? The name of the class is serial out. Not the best name, that's okay. Curly bracket, and then everything from now on, for a while anyhow, is going to be in the class. In C you go, C++, sorry, you say private. And these things here are private to this class, so only this class can see these bits of information. So this could be, there are two types of things that are going in a class. There's a data field, or in this case an instance variable. So that's what these things are. These are instance variables, or they're fields within the class. So these are things, bits of data that are attached to the class. And then there's also what I will call methods. I don't know what they're called in Java and C, but in Java they're called methods, and so I'm just going to call them methods. But they're functions or whatever. Class functions, instance methods. All the thing is that they're bits of code that do stuff, and they get to see what's inside the class. So you can imagine, that they're inside the class and then they can see everything that goes with them. I don't know what that means, but that doesn't really matter. But we have to do the constructor, and C is one of these annoying languages, just like Java, where you have to actually say the word of the class. So so then the class is called serial out. So the constructor is something that has serial outs bracket, a bunch of parameters. So it's like a function, but it's a special kind of function that doesn't return anything, and it's the thing that you use to set up the class. Well, kind of. It's called when you create the class, and we're going to go through a little bit about that, but we're just going to keep it to simple Arduino stuff at the moment. The important thing to note is, what is the important thing to note? The thing that I don't like about this, even though I use Java all the time, is that if it's called like the same name as a class and you change the name of the class, you have to change the name of the constructor as well. And I think languages that have a specific constructor keyword is probably a better way of going. But anyway, this thing constructs the object. So when you construct the object, that's the best way of explaining it, it calls this. So we can construct it with 3 bytes, and these are the data pin and the clock pin and the latch clock pin. And then what we do is we take these parameters to this function or method, and then we store it inside of these things here. So we're going to store it inside the instance variable. So we have to do this. So in this case, that's what this is saying. This is saying this object's data pin field, we're going to put the parameter data pin. So this data pin here is going to be stored in this variable here, and so on for here. Sorry, I've put an underscore at the end of the instance variables. I always put underscores at the end of instance variables. I think very few people actually do that. It's just something that I particularly do. So if it's a parameter variable or a local variable, it doesn't have an underscore at the end of it. So that's why I have all that. We have to use this funny notation here with a little minus and greater than sign. That's like the arrow pointing in there. So we're going to go through this. This is the annoying thing about C, is the way that you have to reference things, or dereference. I keep forgetting the term. But we're basically storing these things here. There is an actual better way, well, not better way, there's a different way of doing this in C++, where you have to do some sort of weird notation over here. But I'm not going to go through that because I've never done it myself, and it's kind of confusing if you're a beginner, and if you're a Java programmer or something like that, it doesn't make any sense. So we're not going to talk about that kind of stuff. And down here we have our first method or first instance function, a function of the class. And this function is the init function, so I've gone and separated these things out. I've done this because this seems to be the way that most Arduino stuff are done, though I suspect I might be able to get away with doing this code in here. I'm going to talk about why I don't know whether I can, because I haven't experimented and I don't know everything about Arduino, but we'll come to that in a minute. But anyway, all this thing does is it sets the current value to 0, so when you init So there's also a current value field up here as well, which we'll come into a second, and that just goes through and sets the pin modes for each of the two latch pins and the data pin to output. So that's what that's doing. So that's the init method there. So that's the same kind of code you might do outside of the class if you were doing it normally. And now we're going to come down to sorry, the actual methods that are used in the class. So these are the things that the class can do. So one thing we can do is we can set all. So the idea here is we have an 8-bit byte, and that's going to store, if you imagine it as a binary value, the current state of the LEDs. And this thing is going to convert that to serial output and so on, which we'll get to. So when you do this, you're setting that byte directly. So this thing here is just getting the value of that data directly. But we can also set it bit by bit. And this is where it's going to get slightly complicated. And so this came, we have a set, and so it's going to look kind of fine for now. It's going to say this current value equals. I haven't done anything fancy with a fancy equals thing here, so we all kind of keep it simple because it's too very complicated as it is. But this something equals this current value, and this straight line symbol, and something referencing the arrays that I had from beforehand. So these two arrays here are going to come into play. So these are like constants arrays. So they're not really constants because you could change them, but I've put them in capital letters because I'm treating them as something I never change. But I'm going to use them as a lookup table to do a little bit of trickery. So this is going to take the current value, and it's going to do this funny little line thing mixed in with the value. So let's just say we're doing bit 0, and we've got what do I call it? Bit values. This is a bit strange. Bit values. So saying we're going to set bit 0, well then 0 of that array is the number 1. So this is going to say, basically we're going to take the current value, do the funny whatever this line symbol means with the value of 1, because we're reading in value 1 because we're just pretending for now we're using this set method with the value of 0. 0 is the index into this array, which is 1. If it was 1, it would be 2. If it was 3, it would be 4, and so on and so on and so on. You can see these values go 1, 2, 3, 4, 1, 2, 4, 8. They're just doubling by each time there. The decimal equivalent of 1 is 0, 1, 0, 0, 1, 0, 0, 0, 1, and so on and so on and so on. So this thing here, to give it away, this is the OR symbol. So this is saying this value or this value here. And that might sound strange if you've only done like if statements where you said if this is true or this is true. Here, this is the numerical or the integer OR. It's not the Boolean OR. It's not comparing two values. It's basically merging them together in a particular way. So we're going to jump onto that. So let's just say we have. So in here, what I'm going to, I've got the word mask here in the input. It could be A or B. And then what I've gone doing here is this is the input and this is the mask. But this is basically, it's symmetrical, so it doesn't really matter. This is value A on the left hand side and this is value B on the right hand side, but you can swap them around. I don't think it makes any it won't make any difference for AND and OR. But basically, so this is an example. So this is a binary number. This is my input value, and this is what I'm going to call the mask value. And then if I do the OR operation, so this basically says if the OR operation will take 2 bytes and go through bit by bit. So this bit here, 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 there, and this bit here, and do the binary OR option or the Boolean OR option. So if you remember back from when I talked about that a while ago, 1 or 0 is going to be, I've got them down here. So this is how the operation works out. If both of them are low or 0 or false, then the answer is false. So if something is false or something else is false, then they're both then then that's not true. So basically it's like imagining if you say if it's green and round, if it's green or round, well, no, I could say this object is green or round, and if that object was neither green nor round, that would be a false statement. But if it was either green or round, or both green and round, then that statement is true. So that's kind of how that works. Sorry. And if you go back to here, so if I go 1 and 0, so 1 and 0, basically the answer is always 0, is always 1, except if both the inputs are 0. So here, one of these inputs is 1, so the output is 1, but both these ones are 0, the output is 0. One of these is 1, the output is 1. One of these is 0, no, both of these are 0, so the output is 0. And all of these have at least a 1 here, so all of these have a 1 on the output. And in fact, that's the kind of trick I want to get to, is that any value in the input that is 1 is going to be on the output a 1. So it doesn't matter what the mask value here is. If the input has a 1 and you do an OR operation with the mask, you're always going to get a 1 at the output. So it doesn't matter what this value is here. The same thing applies here. If you have a 1 on the mask, that will turn the output value to 1 no matter what the input value was. And that's actually the hint to what I'm trying to do here. So there are probably much better ways of doing this, but this is the way I grew up on a Commodore 64, and so I'm just going to do it the Commodore 64 way. And that is to basically use an OR operation. So basically, if you want to turn bits on for a number, you OR it with a number which has 1s where you want the bits to be turned on. So saying in this case here, I want to turn on the top 4 bits. My input is this, and then I OR them together. Well, I have in my answer the bottom 4 bits from the input, but now I've set the top 4 bits to be 1. And so over here, what I've got with my bit values is, as I said, 1, 0, 1. This is in binary. 1, 0, 1, 0, 0, 1. 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, and so on and so on and so on. So all of these numbers have exactly 1 bit on, and that bit that is on is the index into that array. And so when I come down here to my next page, and I do the current value ORed with this value here, which is going to be 1 bit on for that particular thing, I'm going to end up with a result which is the original value that my current value, plus I'm going to turn on 1 particular bit. So that's how I can set a particular bit at a time without disturbing the rest of the bits and my current value. We haven't quite got to the point where this actually goes through to the 74hc595, and we're going to get to that soon. But we're going to talk about these things now. This is going to take 2 videos. Cool. And this one here is the clear method. And this works in a very similar way, except this time we're going to do an AND operation. So we're going to look back at this, and we're going to use a different array. And we're going to talk about why that is in a second. But first we'll go back to here. So on here, remembering what the AND is, if I say something is green and round, that is only true if it is both green and round. So if it's green but not round, that's false. And if it's round but not green, then it's also false, that statement that I made about this thing that I have. So this is how you get the truth table for this, which is 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, but 1 and 1 is in fact 1. And so if I have my input and my mask, then what will happen is anytime there is a 0 in the mask, the output will be 0. So it doesn't matter what the input was when there's a 0 in the mask, because the output will just be 0, because you know at least one of them is 0, and so the answer has to be 0 or false. So one of them is false, so the answer is false. But if there's a 1 in the mask, then you get a different effect. You get a copy of what the input was. So if the input was 1, then you'd have 2 1s, and so the output would be 1. But if the input was 0, then the output would be also 0. So when you have a 1 in your mask and you AND them together, then you keep the original input for any place where you have a 1. The bit is set, or is set to 1, but you clear any input where the mask is set to 0. And so basically what I'm doing is the same kind of thing, except I'm using a different array. And if you look at the different array, it's actually basically this array here, but I've subtracted off the value. So 255 is the maximum value that I can put into a byte, which is essentially every single bit being 1. So that's 1 1 1 1 1 1 1 1. So 8 ones in a row is 255. But if I subtract 1, then I end up with 0 followed by 7. I don't know if that's going to show up on the camera, if you can even see this. I need a bigger, we'll write it somewhere else. We're gonna end up with, I don't want to use this felt tip pen. Oh, it's too late now. Where's that other piece of paper? I don't want to use it because it's going to go through the paper. So I start off, and if I have 1 1 1 1 1 and I subtract 1, I'm going to get 0 1 1 1 1 1 1 1. So there's 8 bits, and the first one is 0. Now if I subtract off 2, I'm going to end up with 1 0 1 1 1 1 1 1, and so on and so on. So this array is just basically in binary these things here. So in each case, most of the bits are 1, but one of the bits is 0, and the particular bit that is 0 happens to be the index into the array. And so when I come down to clear it, I'm basically ANDing it with my complemented array. And so going back to here, most of the input, most of the mask will be 1, except at one location where it will be 0. And so the output, if you AND them together, will be the input except at the location where there was a 0 in the mask, in which case that will be a 0. So that will clear a bit in the in your data. So this will take the original data, clear one bit, and store that back where it was. So this is how the set and clear functions work. This is a set and update, which I just threw in for silliness, because we're just about to talk about, in fact I might just finish before I get to it. Clear all, just quickly say what that one is. That's pretty obvious. It just sets the current value to 0. Set and update does the set, and then it calls update, which we haven't got to next yet. I don't know if I'm going to have time to do it. So we're going to finish up here. Update is the method that actually does the clocking and stuff, and actually sets the I'm not entirely sure why I've done this. Actually sets the value. Actually shunts out the current value to the 74hc595. So up until that point, the 74hc595 just basically has whatever it had beforehand. It's only when you call this update method that you update the actual display. So you can go through and then set a couple of bits or completely change it around and do whatever you want, and nothing will happen on the actual LEDs until you call update. So update is the thing that is going to do all the work. I think we can actually talk about that, because then we can finish the next video talking about how I actually use the class and a few more bits and pieces about that. But basically, I think I started off by setting the latch pin. Oh, okay, right. So I set the latch pin to low, and that's because the output only changes when you go from a low to a high on the latch pin. So I'm just starting off, before I do anything, I make sure that it's low. And then I use this handy built-in function to the Arduino library, which is the shift out, which basically does exactly what you want it to do for a 74hc595. So it just takes a data pin, a clock pin, this value here, which tells you if you want to shift out the highest bit. So if you want to go, so let's just say you have 0, 1, 2, wait, 1, 1, 0, 0, 1, 1, 0. So probably you can kind of see it. If you want to, so if you go most significant bit first, that's going to take this one out first, so it's going to shift out this bit first, and then that bit, 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 and then that bit. Actually, it's not, because this is upside. No, that's right. Yeah, that's right. So this bit here for you, I'm hoping, because it's upside down for me. But this bit here, I just realized I'm getting confused because I am actually starting to think upside down. So I think I'm getting it right, but I'm thinking I've got it wrong because I'm confused about things. So this value here is worth, basically, if this was on and the decimal value, it would change the decimal value by 128. So if this became 1, the number that's stored here would increase by 128. Whereas if you turn this one on, the number would change only by 1. So this is the most significant bit because it has the most effect on the value, and this is the least significant bit. So that thing here is just saying, do you want to shift this one out first and shift it that way, or do you want to shift it out that way first? And which apparently wasn't in an earlier version of the Arduino library. So sometimes you might see code that doesn't have that particular thing, and then you try and compile it and it's missing this function, this parameter. That's just what you need to add in, and then you have to finally specify what the actual value is, and you call that, and it will shift it out to the 595. I'm just going to say 595, but then of course nothing will change yet because it has an internal shift register and it has the output register, so you have to then shift the latch clock to high, and on that little switch from low to high, then it will latch and copy across from the serial to the output. So that will give you the result that you want. So that's the basics of how that class works and how the 74hc595 will work. We're just going to, next time, I'm going to come back and we're going to talk about how you actually use this class, because it's all nice and cherry just writing out what the class does. I'm going to just go through how I've used it to make this little pattern thing here and what the rest of the code is, and also some notes about the order that I put the code in, and what you would have to do if you wanted to change the order around, or if you wanted to push things into separate files, or ultimately if you wanted to make your own Arduino library. So this is like the first step to making an Arduino library, is understanding how this works. So cool, thanks for watching, and we will continue with this next time.